Hey guys, so remember last week we started talking about transformations and we had looked at several equations and we came up with our parent tables for them. So now we're going to see how we can use them. But first, let's talk about what we did there towards the end where we talked about each of the equations with A, B, H, and K. So I'm just going to pick one of those equations that we looked at, and so I'm going to pick the quadratic one. Doesn't matter which one, I'm just picking one. And so remember, we talked about each of these variables had their own job and what they were going to do and what they told us. So let's go back over them. First thing is anything that is not inside with x is outside. Therefore, that means it is not inside with x. It's not going to be horizontal, so everything on the outside is going to be vertical. So the A and the K are both going to be vertical. But let's talk about A. So we know A is vertical, and because it's being multiplied times a parenthesis, anything being multiplied is going to be a stretch or a compression. So that means A is going to be our vertical stretch or compression. Now, if we multiply by a number greater than 1, things get bigger. So therefore, if it's a number bigger than 1, it's going to make it a vertical stretch. And if it's between 0 and 1, it's going to make it a vertical compression. But remember, if A is negative, that negative has its own job. That negative would tell us that it's a reflection across the x-axis. Alright, now let's talk about K. K is not inside with the x, so therefore it's on the outside and it's vertical. It's being added or subtracted, and anything added or subtracted is going to be a vertical shift. So vertical shifts go up or down. So if it's a positive K, it's going to go up, and a negative K would go down. Now let's talk about what's inside with x. X is our horizontal axis, so anything inside with x is going to be horizontal. And so we have our B and our H here. Now B is being multiplied times the X, which means it's going to be a horizontal stretch or compression. But remember, we also talked about that anything inside here with X always does the opposite. So even though we know when we multiply by a number greater than 1, it should get bigger and stretch it, with B, we know if it's greater than 1, it's going to be a horizontal compression, which means then if it's between 0 and 1, it's going to be our horizontal stretch. H is inside with x, therefore it's horizontal. It's being added or subtracted, which means it's going to be a shift. So horizontal shifts go left or right. And remember, so if we have a negative h, we're not really going to go to those negative numbers. We're going to go right. And that means that if we have a positive h, we would go to the left. The square here, guys, just tells us what our parent function is, okay? Remember, it could be anything other than a square. It could be a cube. It could be absolute value bars. It could be a radical. That just tells us what our parent table is. Alright, so let's look at example 1. Example 1 says use the graph of f of x equals the square root, that's the absolute value of x. Obtain the graph of g of x equals the absolute value of x plus 3. So first let's talk about what's that plus 3 going to do. We'll compare it. Where is it at? It's at the very end, not inside with x. Not inside with x means it's going to be vertical, and because it's being added, we know it's going to be a shift. Vertical shifts go up or down. It's a plus 3, so that means we're going to go up 3 units. So to graph this, we're going to look at our parent function first. So let's look at absolute value of x. So remember, we built our tables the other day, and we said for absolute value, we're going to use the points -2 to +2. And we took the absolute value of each one of these and found how far they were from 0 and put that down for those y values. So for my transformation table here, what is that 3 going to affect? Is it going to affect my x or my y's? Well, it's not inside with x, so it is not going to affect x. So therefore that plus 3 is only going to affect our y's. And what are we going to do to our y's? Well, remember it tells us y does what it's supposed to, so it says we're going to add 3 to it. So let's take our x's right here and let's copy them over here. There's nothing inside with x to change them. And then we're going to take these y values here and we're going to move them here, but we're going to add 3 to them as we do so. So our first one was 2, we add 3, we get 5. Second one was 1, add the 3, you get 4. Third one is 0, add the 3, you get 3. The next one was 1, add 3, you get 4. And the last one there was 2, so add 3 and we get 5. And so now we've got our ordered pairs and we can come over here and graph it. Now while you're doing this, remember what the shape of an absolute value looks like. It's not going to change shape, it's just being moved around. And so we're going to plot these ordered pairs. So -2, 5, -1, 4, 0, 3, 1, 4, 2, 5, and then we're going to connect them and put arrows because our graphs keep going. It's still a V-shaped, and if we compare it to our parent function, it actually did move up 3. So that's how we do vertical shifts.